Hey adapters, welcome back. Joining me today is Matthew Maroon. Matt is the CEO of CMotive Technologies, a startup commercializing the next generation of ultra-high efficiency electrostatic machines for e-mobility and renewable applications. Matt has held product management and leadership roles at 6 prior startups in energy storage, bridging the gap from lab bench to recurring sales. CMotive harnesses the power of static cling to breathe new life into electric machines. Electrostatic machines deliver high torque and ultra-high efficiency at low speeds, all without any rare earth metals. Today, we're going to learn how this new approach will transform how society generates and uses electricity. Hi, Matt. Welcome to the show.
Hey, Doug, thanks for having me.
All
Great
right.
to be here.
I'm excited to have this episode. You guys are doing some really interesting work, and we're going to walk through what your company is all about. But yeah, I guess just first starting off, what is CMotive?
CMotive. So we are the world's only company that is commercializing electrostatic motor and generator technology. Most people don't realize how important motors and generators are to everyday society, but just a couple of fun stats. So 95% of all electricity that is created and put out on the grid comes out of an electric generator. So whether that is powered by cold, turning steam, or whether that's a wind turbine, almost all of the electricity comes from a rotating shaft inside of an electric generator. It's almost the same story at the end of the line. So if you look at how electricity is consumed in the US and across the world, nearly 50% of all electricity gets consumed by an electric motor. So these are really the foundation of modern society. And what we're doing is creating not just the next generation, but really the next platform for how we are going to enable the next generations of e-mobility, renewable generators, more efficient industrial operations. So I'm really excited to talk a little bit more about the technology and how we're bringing this stuff to market.
Okay, so I think that's a really important point about you're reinventing the electric motor. Please elaborate on that.
So electric motors, all right, so this is the simplest way to explain it. And this is how I have to explain it to my parents, my younger brother, people that don't live and die by this every single day. So we all remember running the experiment as a kid where you take a nail, you wrap a copper wire around it, you connect it to a battery, and you create a magnet. That force, the way you're able to do that current, that electrical current that passes through the copper wire creates a magnetic field. In traditional motors, and what we have lived with for the past 125 years, they use that magnetic field in order to induce motion. What we are doing is like doing a different experiment as a kid. So we all remember taking a balloon, you rub it against your hair or wool sweater, and you create a static cling on the surface, a static charge on the surface of the balloon. That's the force that we are using. So we are getting rid of magnets. We are getting rid of almost all of the copper inside of our machines. And instead of using current passing through copper wires and creating magnetic field, what we do is we put a high voltage inside of our machines on printed circuit board plates like these that create a static charge on the surface and interact to create motion. So really, it's an old concept that goes back to Ben Franklin, but no one has been able to commercialize it until today.
Okay, so if you're trying to explain to someone, well, why is your way better than the other way?
It's really about efficiency. So if you use high voltage like we're using, if you use this static cling, so again, it's just like the other way to think about it is the force that holds your socks together when you pull them out of the dryer. It's that same static electricity force. Because we're using higher voltage, we don't create any heat inside of our machines, and therefore our efficiency is higher. It lets us develop high torque or high twisting force at very high efficiencies and at very low rotational speeds. And that is kind of a open hole in the market right now and lets us not just develop, but really bring these high efficiency markets to product and save customers money on their utility bills and therefore, carbon dioxide emissions from just needing less electricity.
Okay, so I'd mentioned in my introduction the idea of rare earth, materials that are used in the other type of machines. What's the big deal about using those? Why is it better not to have to use those?
So rare earth is kind of a weird misnomer. So they're called rare earth metals on the periodic table, but in fact, they're not all that rare in terms of the ability for us to mine them. The issue, however, with rare earth metals is that it's quite difficult in order to transform them from ore that you dig out of the ground into permanent magnets. It's dirty, it's relatively unsafe, it's pretty energy intensive process. So there's been a lot of price volatility with rare earth metals over the past decade. So you can imagine if you're building or even buying traditional electromagnetic motors that are reliant on rare earths, there's been an awful lot of price volatility there. So in addition to just, we should do better in terms of our material sustainability as a society, they're not always the best for keeping low prices and eliminating that price volatility for both suppliers as well as consumers.
Oh, and I guess too is the idea of mining these rare earth metals, even if they're not that rare, there's pollution aspect of it, sort of, I guess, the supply chain of it all that you're kind of eliminating with what you're doing.
Yeah, there's an entire trickle down effect for any of those sorts of mining activities. So moving away from rare earths, and again, the other interesting aspect is we use very little copper inside of our motors, and so you don't typically think of copper as that rare of an element or that important, but as we continue to move for more and more electrification, copper just becomes more and more important, and the more important it becomes, the more price volatility is going to be represented in that raw material. So, yeah, we're excited about taking this kind of totally different approach to this technology and seeing how it works.
Okay, so you had mentioned in a previous conversation about like this tech, the tech and the concept actually been around for a long time, but applying it at what you're doing here is there anyone else doing what you're doing at the moment?
There's been on and off people researching, really kind of in academia, looking at how can we use electrostatic machines, and really the best that anyone's been able to do is the power levels have been kind of measured in milliwatts. And so we're now in the kilowatt range and moving very rapidly into megawatt size machines. So anyone that's done this in the past has really taken a very deep look at one very narrow area of the science. And what our co-founders, so Justin Reed and Dan Ludis, who are our Chief Technical Officer and Chief Science Officer, they really started working on this when they were getting their PhDs at UW-Madison. And so their approach was a little bit different. They decided, well, let's not go super deep in any one area, but let's really take a multidisciplinary look at how to optimize the mechanical design, the electrical topology, the chemistry of the system. And it's been that multidisciplinary approach that's really given us the gains. And, because we got smart people here, because of our IP protection, we don't see anyone else in the marketplace that's working on this right now.
Okay, you mentioned earlier just how motors are used in electrical generation. It's just almost everywhere. Just even as a startup, where do you kind of see yourself fitting in? There's big industrial uses. There could be just tiny, motor uses. Where are you kind of starting off there?
Yeah, so this is the challenge that every startup company goes through: is how do you pick a place to start? You have this. And I think everyone has this amazing technology that could go in 10 different applications or 100 different applications. And for us, looking at a $50 billion marketplace, there's no limit to what we could do. So we are focused right now initially on building industrial torque motors. So, it may not sound like the sexiest application in the world, but things ranging from high efficiency conveyor belts to direct drive fans, pumps, motors, industrial equipment. There's a tremendous amount of electricity that's used across the industry that can be saved by having a more efficient product. So we're starting there, kind of starting small and crawling before we walk, before we run. But in the meantime, we're not losing sight of our ultimate goals of getting into e-mobility and renewable generation.
Well, you must also, I think of the idea of just the energy generation, like generators out there, like even after storm events or in, developing countries, that the idea that you have a more efficient process to kind of generate electricity in these places, that must be, there's all sorts of exciting areas that I think, would have very, social good applications.
Yeah. Things as simple as marine hydrokinetics, tidal energy and riverine energy. These have been concepts that people have worked on forever, but they just haven't been able to hit the economic price point that, people need to buy those products. And a lot of that cost of that generated electricity is driven by inefficiencies in the generator. So as we continue to develop our technology and move it out into those applications like tidal generation and riverine, hydrokinetic energy, we expect to unlock a lot of those new renewable energy sources that just simply haven't been cost effective in the past.
So again, I guess when you're working with a client, there is that you're sort of meeting. They come with you with a particular need, and you actually sort of do tailor-made approaches to what they're doing. Right? That's not something they're buying off the shelf with what you're doing. You have to sort of tailor-made their needs.
Yeah. So early on, certainly a lot of our machines and our customers, we're building bespoke style machines for customers. But our intent is to get, take some of the things like, look the wrong way here. This one back here. It's going to be the first product that we bring broadly to market later on next year. And so that's between a 1 and a 5 kilowatt motor, and it'll be very standard. And you'll be able to basically call and order that sort of thing. But, as we look at specific applications, if a specific customer has a very targeted, torque rating or speed range, we can certainly dial in the technology for those specific applications.
Okay, so the one you just showed me behind you there, what would be an application? I mean, where is that kind of showing up? What would be something I even would recognize on how people might be using it?
So that this size motor is like perfect for material conveyance systems. So whether that are conveyor belts, pick and place robotics, lifting applications, almost all of those are in kind of the sub 10 kilowatt range. And so it's really kind of a multi-purpose sort of motor that's going into those stationary industrial applications.
And the issue of weight too, you look at these things and where you're transporting all these, like you can have like your comes in at much lower weight too, and you're delivering still the same energy level. Could you maybe elaborate on those specs? I really want to kind of cover those specs.
Yeah. So probably taking a step back and thinking about what are our motors made out of and why would they be lighter weight? So the one behind me is made out of aluminum. It's got a little aluminum case, aluminum front plate to it. So obviously pretty lightweight materials there. The inside, this plate that I showed a little bit ago, this is a printed circuit board plate. You can basically buy them anywhere. They're very standard products, lightweight because they're made out of polymer. And then our machines are filled with a proprietary dielectric liquid, which is kind of the whole secret sauce behind what we're doing. So, we're not using cast iron as our outside housing. We're not using permanent magnets. We don't have kilograms and kilograms of weight of copper wires on the inside. So when you look at torque per unit weight, today we're about 3x better in terms of torque delivery per kilogram. And as we continue to work through our technology roadmap, we're going to be 5, 6, 10x better torque density. So mobile applications, aerospace applications, places where you really want to save weight, this is an ideal sort of technology for those motor applications.
Okay, so this sounds like there's just a ton of ways that this can, the applications, but what are some of the challenges of scaling what you're doing here?
So again, it's kind of the challenge that every startup faces is how do you go from 1 unit to 10 units to 100 units? And so, that certainly manifests itself in upfront design for manufacturability. So making sure that what we're designing can actually be produced outside by third-party contract manufacturers. But a lot of the challenge that we have right now in terms of getting this tech out into the market is just educating people that there's a new way of solving their problems. So like so many other technologies, a lot of people are very comfortable with the devil they know. And so a lot of the resistance that we find in the market comes from people saying, well, I've always bought an induction motor or a brushless DC motor. It's always worked for me. And yeah, I got to buy a gearbox. Yeah, I got to worry about active cooling. But no one ever got fired for doing the thing that they did yesterday. And so a lot of what we have to do is continue to not just provide the test data, not just provide the evidence, the case studies, et cetera, but really do things like this, which are educating people that there's new tech out there that not only works, but certainly can solve problems they have and be a new tool in engineers' toolboxes for future applications.
So I've talked to a lot of people in the renewable energy space, and I want you to talk a bit about that because there's obviously all these applications that your technology can be applied for, but the renewable energy sector, where do you guys see yourself fitting in there?
Yeah, certainly on the generation side. So, Smaller products for us, kind of think below 100 kilowatt in that sort of marine hydrokinetic generator space. So riverine, tidal, that sort of energy generation. We believe that this is an ideal technology for wind. So whether that's onshore wind turbines or even offshore wind turbines, our ability to scale up these plates to very, very large sizes and deliver 99+% energy efficiency generation is what's going to bring us into that market. We know it takes a lot of development time and it takes a lot of validation testing in order to get there. So we're starting that work now, but keeping our eye on the prize for 5, 6, 7 years down the road when we're able to deliver megawatt class generators into wind turbine applications.
Well, there's a lot of chatter about investing in infrastructure, and renewable energy is a big part of that. It just seems like the timing could be really good for what you guys are offering here.
Timing is everything. So this is a good time to be in the clean tech space for sure.
All right, I want to talk a bit about climate change. And so let's say you're partnering with groups that are doing renewable energy, but when you talk about your technology, does that come up? And even, I guess, as you're trying to sell the technology, like you're part of this solution to this bigger issue of climate change, does that come up much? Is that part of your marketing?
Yeah, it certainly does. So it is certainly part of the marketing that we do. It is a differentiating factor for us compared to traditional motors. And really where we see it a lot is a lot of the customers that are interested in our product and in partnering up with us early have made public commitments to reducing carbon dioxide emissions or adding more renewables or just something in relation to addressing their impact on the climate. And what I think we see and is reflected by a lot of these big companies that are joining like the RE100 list, for example, is they're recognizing that addressing climate change through what they buy, what they produce, how they sell is not just good, public image for them. It's not just good for the environment, but it's good for a lot of cases, their bottom line as well. And so as a young engineer, once I had someone tell me that at the end of every good engineering equation, there's a dollar sign. And I think that's absolutely true. So companies will continue to look at what they can do to reduce their energy usage, to add more renewable energy, but they're only going to do it if it makes economic sense. And so that's really where our ability to deliver that higher efficiency, avoid those potentially cost problems of rare earth metals and copper, it puts us in a really attractive spot when companies are looking at partnering with someone for the long run.
You obviously have to talk a lot about what you're doing there. Are there any misconceptions, I guess, ones that come up quite often that you have to talk about this technology that you're working with?
Yeah, I mean, again, I keep going back to the same expression, but every startup runs into this, right? It's the question of, well, why hasn't anyone done this before? What makes you special in your ability to go do it? And so a lot of the misconceptions we have, we can address through, hey, look through our public IP portfolio records, right? Look at the work that we've done. Look at the test data we've been able to generate. Talk to the team here and look at how many years of school and experience we have in this area. It is a show me market for so many different products and so many different applications. And we're no different. We have to come to the table with data and come to the table with the proof, and that quickly dispels a lot of those misconceptions.
Yeah, I did look at your staff page, and there's quite a few technical experts on it. Yeah. That's who you're hiring, and which makes a lot of sense. All right. So you've explained what this technology is all about, but you also mentioned, like, when you explain to your parents or your neighbor about what you're up to, you're sitting on the bus. How would you do an elevator pitch to someone what you're up to here? What would you say?
I mean, we're really trying to change a way that we fundamentally produce and use electricity. And the elevator pitch is really about efficiency and efficiency in the use of electricity and the efficiency of the use of raw material resources that we have. So CMotive is taking an old concept and applying modern material science, modern power electronics to an old problem, to take static electricity, which we experience every single day, and kind of use it to our benefit. And that's the heart of what we do, is try to take this really cool technology and create products that people are going to be happy to buy and install in their facilities, wind turbines, or even vehicles long term.
All right. So what's next for CMotive? What's sort of the near and midterm for you folks?
Yeah, we are. So as I mentioned, we're bringing out our first product line next year. So we're actively working with kind of early adopter customers on demo units and some pilot projects this year and next year. So we're always open and excited to talk to people about their motor needs and whether or not a demo project with us over the next 6 months makes sense. And then from there, it's really about scaling. So we'll be entering into a fundraising mode over the next few months, allow us to build out our staff. So we're at 16 people right now. Let us add, 10, 12 more people to really augment our commercial and our operation teams and take this technology and move it out into the market. So we're making that transition from lab bench to real product. So it's a very exciting time to be part of the company. It's stressful because there's still a lot that we have to figure out, but it's very exciting and nothing but optimism here in our ability to take what we know and really do some good out there in the market.
Okay, and just I guess final note here is if people want to learn more about who you guys are, how do you recommend they could sort of do that with potential clients or just they want to know technology? Where should they go?
Yeah, best place to go is the website. Obviously, it goes through a lot of the information that I've talked about today and a little bit more detail for people that want to dig into the science. From the website, you can certainly find ways to email the company, the info@cmotive.com. We're also doing a lot on our LinkedIn page as well, trying to share articles and certain thought pieces about how we're looking at the world, where CMotive might work. So I'd encourage people to take a look at the website, take a look at LinkedIn, and reach out to us through either of those two platforms.
Well, Matt, it's been a real treat chatting with you here on Simpatico. We love telling stories like this. You guys, it's all sorts of exciting tech coming online, and you guys are just right there at the forefront of that.
Yeah.
So
thank you, Doug. Appreciate that.
All right, I want you to hold on. We're going to go into just chatting before we wrap up, but I want to thank everybody for joining it. Hey Matt, we're back. We have a closeout scene that we close the episode,
Sure.
and we're still streaming, but we just like to just kind of touch base, just wrap it up. I won't keep you on too much longer. That went well. That was great.
It was great. Thank you very much.
Yeah, I think you did a fabulous job. Just all right. Let's hear who you guys are. So I think it went well.
It is. I mean, it's a challenge that a lot of us have is just getting broader brand recognition and validation of what we're doing. There's been a lot of vaporware out there in the past with a lot of different technologies. There's a lot of different claims made. And so anytime you got new tech going after an old historical market, it's hard to sometimes break into it. So these are great opportunities for us just to hopefully reach more people and get people thinking about what they could do different if they weren't constrained by what they've always done. So this was fun.
Well, yes, and we work with companies too. Maybe there's a particular software, maybe there's particular tech that you're going to want to highlight an episode, and we'll be in touch. And this episode will be available hopefully in the next 24 hours that you guys are going to be able to use, and we'll just kind of follow up with you guys if you see some potential opportunities there. So
yeah, we definitely want to do more. I think what we want to figure out is what can we do next that's not just kind of a repeat of what we've done here. And so, whether that is an actual demo that we have running in the background, just something a little bit more like, hey, let me show you how this thing works. That's really where we'd like to go next. So I'm hoping, things always get a little hectic between in Q4 certainly, but.
Sure.
Between now and the end of the year to come up with a plan and then try to get something on the calendar for Q1 next year to do a follow-up.
Yeah, that'd be great. One of our clients, just the first episode spotlight on who you guys are, but then we went just straight into all right, here's software that they're doing. And so, and they can kind of use that approach to it. So there's all sorts of different ways with it we can.
Yeah. I mean, if we've always talked about, what's too much on the technology, but, we could certainly get Dan Ludis to come in here and, do the professor thing in a whiteboard and just go through hey, here's how this thing actually works. It's not really, broadly public consumption, but, there are always people that are interested in going deep on that sort of stuff.
Yeah, you're not gonna have Game of Thrones level audiences, but I also like to think that I have a good way of sort of dispelling this sort of,
Yeah.
this is what it's about. Just kind of, Homer Simpson, dumb it down for me. What are you guys really
Yeah.
doing here? And that's, we like to think that we're, dumb it. That's not probably not the best pitch,
No,
but,
I get it.
just they can consume it and understand it. You don't have to waste a lot of time on the technical side of it. So
Yeah.
that's what we do here. Well, I'm going to let you go. I appreciate that, and we will just be in touch with your team about what we have here. And such a treat having this conversation and working with you guys.
Yeah. Thank you so much, Doug. Appreciate it.
All right, you can just sign out of.
All right. Talk soon. Bye.
All right, folks. We're not streaming to Symphonica, so I'm going to do a wrap up here. And thanks to Matt and the work they're doing at CMotive. Very exciting. So we'll see you next time.